Okay, here we go. We have vectors. Vectors, I would say that this content is significantly easier than what we've covered the past couple days. I think you guys will find it refreshing. It is new, but there's a lot of pieces that you can connect with. So if I have a vector here with an initial point P, that means where it starts. And then a vector has direction. You can see the arrow. It's headed in this direction. If we put a point on the end, that's where the vector stops. So you don't want to think of a vector like a ray. A ray has a beginning point and it has no end. It goes forever in that direction. A vector definitely stops. So, um, the magnitude of the vector is simply that length. So it's the length of P cubed. I was going for 3. All right. Okay. Given the following vector, draw an example of the following. So, if this is our vector v, I want to draw negative v. And negative v would go just in the opposite direction. We have the same starting point. It would just head in the opposite direction. Oh, do that a little bit more. Try that again. Okay. Second chance. Is that? Nope. So it's going to start kind of at that same height, so to speak. Whereas 2v will start at that same spot, but then it will go twice the distance in that same direction. What do you think 1/2 v will be? Half distance. And then negative 4v, what will happen there? Opposite direction. So something like that. Okay. Was that too far? How's that? Alright. So sketch examples of the following. This is A, this is B. So vector A and vector B. I want to draw negative A. And so I will start at the same point as A does, but I will move in the opposite direction. Negative B. Start at the same point, opposite direction. So A plus B is a different scenario. Now all of a sudden we're adding two vectors together. What happens, you have to think of it as like motion. Think of like a person walking. They're going to walk in vector A, so they're going to walk in this direction this far, and then they're going to continue on as vector B. So after they're done walking A, they will then they'll walk vector B. So if you wanted to show an expression or a drawing for what it looked like to walk both A and B, a person could just instead choose to walk from this beginning point to this final point. So this is actually vector A plus B. So A minus B. I would take A and add on a negative B. We take A, I'm going to add on to it negative B. And so my new vector becomes this. I'm going to take b minus a. So I'll take b and I'll add on negative a. So I'm going to take this negative a, place it right there. So the vector of b minus a is right there. So, component form of a vector, okay? Um, this is kind of the visual representation, graphical representation of vectors. What we like to do is we kind of like to look at the algebraic form. So suppose I have this. I have point P is x1, y1, and that's my initial point. And I have point Q, which is x2, y2. I can come up with what we call a component form of a vector. The vector does have 2 points that help make up its kind of like a coordinate. But to show that it's a vector, instead of using the parentheses, we use those shapes. Kind of like a sideways V for vector. So watch Despicable Me. So the dude's name is Gru and the other's name is Vector. Because he has magnitude and direction. You'll see as we go on. It really is funny. So guess you have to be a math person. Wow. Horizontal component is going to be the difference in the x values. The vertical component is going to be the difference in the y values. So I'll show you an example of what this looks like. It says find the component form of the following vectors. P is the initial point and Q is the terminal point. So if I were to graph this, 1, 2, 3, 4, 5, 6, 7. And just watch. You'll be fine. Don't draw it. Just watch. Sorry. They are a gift. We could take them by hand if you prefer. Over 7. Are you okay with that? Kind of being the drawing of the vector? Okay. So what I'm going to do is I'm going to put this in component form. Component form means I'm going to find a horizontal and a vertical component. How do I do that? I take the terminal point of the x value minus the initial point of the x value. So 7 minus 3 is 4. And then 5 minus 4 is 1. So you can see what I come up with is, watch how I do this. If I take this vector and I just slide it so that its beginning point is at 0, 0, where does it end? 4, 1. So whenever you find the component form of a vector, what's nice is it moves the initial point to 0, 0. It's nice to start at the origin. So that's what we call the component form. I'm not going to draw you guys aren't going to be asked to draw the graph ever. I just did that to help you guys visually once. So right now, on your own, just algebraically, no graph, find the component form of the next vector. Seven, negative 3. We take 4 minus negative 3, and we take negative 1 minus 2. Everybody okay with that? So do you see how when I ask these type of questions on the test, I'll expect that you get them right? Okay, let's flip it over. Now we talk about magnitude of the vector. Magnitude is going to be the length of the vector. So as you look at this last one right here, I'm sorry, this first one, if I wanted to find the magnitude of this vector or its length, what formula would I use? Yeah, a squared plus b squared is c squared, right? So the magnitude of a vector is how far it stretches from the origin in its component form. So given vector v is equal to a b, then the magnitude of the vector, or its absolute value, is equal to the square root of a squared plus b squared. So it says find the magnitude of each vector. Square root of a squared is 25, b squared is 4. I get it. Square root 25. What's the next one? Square root of 0 plus 9 is 3. Square root of 9 plus 16. So again, equations like this, I would write that stuff down on your sheet of notes for summary. Sum and difference of vectors. Suppose you have vector u is equal to a1, b1, and vector v is equal to a2, b2. Then, if I were to take u plus v and add the vectors, I'd simply take a1 plus a2, comma, b1 plus b2. Simply add the horizontal components and add the vertical components. So using this principle, we can also apply multiplication properties. If you had 3 times a, everybody agree that would be a plus a plus a. So that would be 1, 3 plus 1, 3 plus 1, 3. Just be 3, 9. Instead of adding up 3 times, I could just distribute the 3 through, right? So if b is 2, negative 2, what would 4b be? See if we can come up with the next two on your own. Okay, 5, negative 1, negative 8, 16. Right. Vectors in terms of I and j. If you have vector 3, 9, you can write that if you prefer as 3i plus 9j. I don't know why. Your book says it, it uses it in some examples. I did not take an engineering course or anything like that, I don't know if it comes up. I don't really see it later on in mathematics, but whatever. So let me see if you can guess. If you had negative 816, what would that look in IJ for? Yippee. Right. If I give you say 1I plus 4J, I would expect that you could write it like that. Yes. Horizontal and vertical components of a vector. Okay, so um, if I this is the most important part of the day. Suppose I were to take a vector and I have theta, and I have b, a. We'll call this the magnitude of the vector. Can somebody give to me an expression that involves a, theta, and absolute value b? You're right that a squared plus b squared is equal to the magnitude of the vector squared. I want something that involves theta. Cosine. So the cosine of theta is equal to what? A over the magnitude of b. So therefore, if I solve for a times the magnitude of b times the cosine of theta is equal to a. Right? And can I have an expression involving b? What would that be? Sine of theta is equal to b divided by the magnitude of the vector. So magnitude of the vector times sine of theta is equal to b. So you can see that the horizontal component, the a value, is right there. And the vertical component, the b value, is right here. Okay? So we will write that down and we will apply it. If vector b is equal to ab, a is equal to magnitude of b times the cosine of theta, and b is equal to the magnitude of b times the sine of theta. So what we're going to do is we're going to take vectors that have a magnitude of 3 and a direction of 30 degrees, and we are going to turn them into component form. Okay? So, very simple. A is going to be equal to the magnitude of the vector times the cosine of what? 30 degrees. On your unit circle, cosine of 30 degrees comes up to be what? Root of 3 over 2. Therefore, you get 3 roots of 3 over 2. That will be the magnitude of, or I'm sorry, the horizontal component of the vector. In order to find b, so we get 3 times that is the vector in component form. Or you could write it as 3 roots of 3 over 2i plus 3 over 2j. You try the second one on your own. So you get a is equal to 4 times the cosine of 315. And you get b is equal to 4 times the sine of 315. So what is the cosine of 315? Which equals 2 root of 2. Or 4 times negative root of 2 over 2, which equals negative 2 root of 2. Therefore, the component is 2 roots of 2, comma negative 2 roots of 2. We'd like to write that in IJ form. There we go. Okay, we look over. We'll do one last example here. It says find the magnitude and direction of the vector. So magnitude we've already talked about. Magnitude of a vector is equal to the square root of a squared plus b squared. And then for direction, tangent of theta is equal to b divided by a. We will have to solve that argument to figure out what that is. All right. Magnitude of v is equal to square root of square root negative 1, and you get plus magnitude of the vector is equal to the root of 5. You have both stupid for lunch or what? What do I do? What do I do? All right. That's all. Tangent of theta is equal to b divided by a, or negative 2. Uh-oh. Which quadrants is tangent negative in? 2 and 4. Which quadrant am I working in, second or fourth? Fourth. I'm going to get rid of the second quadrant because it's negative 1, positive 2. Oh, no. What are we doing, folks? Because it's negative 1, so we're going to go back 1 and then up 2. All right, so then I got a tangent inverse 2. And if you tangent inverse 2, what do you get? Somebody? Calculator? So we will leave theta in degrees for vectors. And so if we subtract that from 180, we should get 116.57 degrees. For the next one, if you see this problem, you don't like it, you can just transform it to component form. Yep. It says find the magnitude and direction. So that's the magnitude and that's the direction. If you, like I said, the hard content is long. I mean, that was chapter 76. It was yesterday. This stuff is technically new, but we're using a lot of the same formulas. I mean, we're not going real in depth into vectors or polar coordinates or trigonometric equations. We're just going to cover the basics. And as long as you can do this, you could get an A on the test. But I wrote down last year the test scores were very poor for this one. People just never kept up with the homework last year. The previous test they did, but this one, people kind of fell apart. So, I think people miss a lot of days in here, but hopefully as we give you that time, hopefully you're getting caught up. So, all right. We do this one right here, okay? Vector v is equal to that, or 3 root of 3, negative 1. So I have the magnitude of the vector is equal to, square that, and I get 3 over 9, which is 1/3. And square negative 1, and I get 1. And so I get 4/3. Square root of 4/3, we get 2 over the root of 3, or 2 roots of 3 over 3. Then we've got tangent of theta is equal to, or b value, negative 1 over the root of 3 over 3. Now, a lot of people go through a lot of work to simplify that. you don't have to, because that's not our final answer, is it? We just use it to get a final answer. So if you want to rationalize the denominator, go ahead. What I can do is I can just take the inverse, and I'll type in 1 divided by parentheses square root of 3 divided by 3. So if you want to simplify, go ahead, but you don't have to. I get 60 degrees. Which quadrant am I working in? This is the fourth quadrant because you were over 3 roots of 3 and you're down 1. It's 60 degrees. What angle is that? 300. So theta is equal to 300 degrees. So the magnitude is 3 roots of 3 over 3. The angle is 300 degrees. So again, I didn't simplify negative 1 over root of 3 over 3. Yes. You see how I get negative 1 over the root of 3 over 3. So in order to find theta, you take b, you divide it by a. Oh, this part. Yeah. So I square the root of 3 over 3. Square the top, you get 3. Square the bottom, you get 9. Which is 1/3. Plus, negative 1 squared is 1. 1 and 1. Got it? Alright, we pick up with the rest tomorrow.